programming engineers. Again, welcome back to this drives course. In today's topic, we're going to be looking into, and I'm going to be showing you all about the most used and most common formulas at the moment when we try to get a variable in the induction motor world. Electrical variables, something that is missing, something that we need. Now, why am I teaching you this? Why am I telling you about this? Because there are certain times in which we want to run some sort of modification, something that I had previously told you about. Maybe the electrical part, or that I need to get the data for an induction motor. However, or in the data plate, we can't really perceive well those important variables. Or simply put, the motor is so old that I'm not able to view. I can't see it. Maybe the data plate has already been faded away from all the years that it's been running at the company. So therefore, if you know all the formulas automatically then, and you know how to get them, then it's going to make your life much easier, and it's going to save you so much time. Or even hire some sort of an engineer or a technician, and they're going to charge you a lot of money. So it's better if we know how to do this. Okay? So we have our formula for speed in our AC motors. Now, there's many formulas, as you already know, through school. Okay, we were bombarded with different types of formulas, many of them. Now, I'm not saying that they don't make any sense. These are very important as well. I've always said, school helps us out in getting a concept, a pretty direct concept logic, so that we know how to get things. But we need to be very honest on our practical part, the part where we're getting paid for. We are much more practical, and those formulas that they're showing us, they're basically telling us a different way to get that data. But maybe we can go to our more complex part. Now, why go to our more complex part if we can get it to this in the simplest part? Well, these formulas are the easiest ways to get those variables. Now, you can get it any other way. However, based on my experience, I can tell you guys these formulas that I'm going to be showing you are the ones that are going to save you a lot of time. And basically, they're going to tell us how to get the result in a much easier way. That's the speeds case. So we can get speed in another way. But what do you think? Guess what, guys? This formula that I'm telling you about is good if we have our slide. And in general, we're not going to have that on the field. That you can see it in the books, but not here. So what we're going to get here is our frequency and our polarization number. So just with this data, we're going to be able to get the speed. What type of speed? RPMs. Okay? So speed, which is N, equals 2 times F, which in this case, we're going to add here our frequency. Now, this is important because we're already internally analyzing our drive. And its main goal for our variator I had previously told you that depending on the variables, etc., we were going to get different speed and more variables even. However, a very important characteristic of our drive, or our variator, as its name says, VFD, which in Spanish stands for frequency variator. So once we analyze its frequency, we are able to increase or decrease its speed. So frequency is something very important, an important variable for us to increase or decrease that speed. Now, what's the frequency unit? Its units are hertz. Now, this is absolutely necessary that you can continue watching this, the importance of this formula. That's why I wanted to show you guys, okay, so that you guys could notice that as we get more or less frequency, we're going to decrease that speed, okay? So that frequency, we're going to be able to increase or decrease. And the polarization number has already been predefined in our plate number, in our data plate. Okay? So depending on what we're substituting is the RPM speed. Now, the other formula works if we have some slide. Now, generally, since we're not going to have this, that's why I'm showing you this formula. Okay? Now, what other formula are we going to use? Torque or PAR? P-A-R. Now, for this, what is it that we need? We only need our HPs, or our horsepower, and we also need our constant, aside from our RPMs. Now, with this, we can calculate our torque. And we can also guess our PAR. Now, what is this for? Just simply put, if we have an application, let's suppose an application where they're telling us that to be able to move an elevator, we need a torque, I don't know, let's say for 20 kilograms per meter. Well then, what potency are we going to need for our motor to be able to run our movement for that application? Okay? It's as simple as that, guys. If we already have our torque, then we can substitute and calculate for how much are we going to need for our potency in our motor. Okay, so it's pretty indispensable in that formula. And it's very, very simple. It's simply put, HP over times 716 over RPMs. And that part you can start substituting. And finally, which is the most important formula, we have our horsepower formula. Now, what do we have here on the top side? We have our horsepower equals, and this is another way to get our horsepower from a motor. How much would we need? So if we have a voltage, here we have voltage, for example, times A, and A is our current. So voltage times current times the potency factor. Now, where can we place that? Where can we locate that potency factor in our data plate? Okay? Now that potency factor, we can actually get whenever we are looking at a cosine. That's in our plate, that's our potency factor. Done. Now, all this time our potency factor times efficiency. And that's always going to depend on each manufacturer on the motor. Over 746. Anything that has to do with potency factor and efficiency is something very close, very approximate to get realistically our horsepower. If we don't have that data, don't worry about it. Okay? Simply put, as long as we have our voltage over our current over 746, which this is a constant, it's never going to be modified, we are going to get our HPs, our horsepower. Now, here I'm going to leave you our formulas to get our different data depending on what we're missing or what we're over on. Okay? Now our formula, our final formula is potency, electric potency. This formula is very, very important. This is the one that you need to know by heart. Of all these formulas, the one that I would really ask that you guys, again, that you learn by heart is this one. This is the most important one. You guys have no idea I've used this. And basically, this is the one that we need to know whether we want to or not. Potency, remember that its units are in watts. So voltage is measured by volts. And this is important because once we remove all the elements, we're going to be able to calculate with our mind. Okay? So potency, remember that their units are in watts. So voltage times current. And that's why we need to calculate as well our potency for our we're going to need to be able to move our shaft, which is what I've always said. What we really need to move our shaft. Okay? Move that axis for our motor. That's why this formula is so important. Now, if we want to remove all the elements, all we need is our voltage to pass it on to this side, and P is divided by everything. Potency over current. If we want current, then that would be potency over voltage. And basically there we'd shoot from there. And then there's different ways to get our potency, but this is our most general formula. It is like the ohm formula. It's our most general formula, and we can get our voltage in many other ways. But I'm telling you this in a practical manner. Now, the quickest way is through these formulas, through these variables. The other variables that we get in a different way for that result, they do exist, but they're very unknown. Now, this is the easiest way to get this, okay? Now, having said this, now we're going to be able to check our drive internally. So that's what I'm going to explain. So that from there, we can start with our practical part. Okay, so I'll see you guys in our next video.